Hi everyone, it's Adrian here from Sofeast. I've just got another quick bonus podcast episode for you because I was having a chat with our head of new product development, Andrew, recently about whether you should do PCB or enclosure design first, and I wanted to find out what his opinion was. Let's get into that. Andrew, welcome back. Hi.
Hey, Adrian, good to be here again.
Glad to have you on. And the reason for getting you on this time is because we saw a conversation on the Hardware Academy forum, and I'll leave the link to that, listeners, so you can go check it out. It's a forum and a website that helps SMEs and entrepreneurs to get information and support to bring their new product ideas to life and to market. And this conversation was about whether you should do PCB design first or enclosure design first. And actually, there was quite a lively conversation about it. And some people thought the latter and some people thought the former. So I was just hoping to get your feedback on this. Where do you stand? And also, hopefully, you can give us some guidance on how to make the decision on which way to go. I'm assuming, of course, that this is going to be most relevant to people making electromechanical products as well.
Yes, absolutely. I think this was a very good conversation between a lot of engineers in that forum. And I think that really nobody got to in any kind of a conclusion which way is the right way. Well, to be honest, I mean, enclosure or PCB, which one should it be first? Kind of like chicken and egg situation. It is really, really difficult to decide without knowing much about the product. If you are a design engineer that you just kind of settled in your own ways and you always do the PCB design first, well, you may run into some problems when you try to put that PCB in a tighter enclosure that the ID team has already, kind of thought of. And then you'll have to kind of go backwards and split the PCB or whatever else you have to do in order to fit it there. And backwards, just the reverse could be possible. If you're an enclosure designer, and you design the enclosure that is small and nothing is going to fit in there, then there's going to be a war in the office. People not going to agree with each other. And so I think the best way, honestly, is to come up with a process that makes it easy for everyone to understand what is the right way to do this. What's the, in my opinion, honestly, in some cases, designing the PCB first makes a lot of sense, depending on the product. And in some cases, building the, enclosure makes a lot of sense because of the fact that size and dimensions and the ID is more important than what's inside, for example, or what the user expects. Imagine if iPhone was the size of a TV. If the iPhone was the size of a TV, gosh, I mean, I don't think anybody would buy an iPhone. It would be just too big. And, if the enclosure was decided to be that big. So I'm exaggerating, of course, but, everything needs to be down to what makes sense for that product, not only in the design office, with the team, but also with the customers that we're going to sell this product for. If the customers demand a smaller package, then the enclosure is the way that has to go, right? You have to design it for enclosure. But if enclosure is not so important, functionality is important, and you need to build a product that really functions well, then basically you do the PCB first and try and fit them in a format or a package that fits just about right. So I came up with an idea that I think might be helpful, not necessarily written on stone steps or process. I think it's just an idea to help, at least help our young engineers to kind of find their way, which way should be. I call it the 5 steps of basically, the basic design, yeah, of a brand new product that it doesn't exist as much in the industry or in the market. Maybe there is one competitor is just newly, is producing one, or in that kind of a scenario is what we're talking about. Well, the first step is creating a product requirements document, what is called PRD. And typically this comes from, I believe, product engineering team. And they kind of design the form, fit, and function of the early product and the concept product. They come up, it would be nice actually, they would come up with a user manual as well, and preliminary product specification, maybe a reliability requirement, for example, if it needs to meet a certain, for example, drop height. So this PRD would have so much information there that would help at least the design team have an idea of what the product should be like in terms of specification. This could be very useful for PCB designers. However, step 2 would be an ID, industrial design for the product. I know that a lot of us have seen on TV, a guy who is designing a car from a wax. Have you seen that?
Yeah.
He's like scraping a little bit more from the front, a little bit from the back, and reshaping corners and so forth. That's basically ID. And ID, industrial design of the product, is critical to the success of the product. It's kind of like the fashion designer. He's trying to make the look and feel of the product be appealing at the same time functional. And it's really a very, very sophisticated area in the engineering. And through this ID, it gives the engineering team, especially young design team, a good picture in their mind and the image of what the product is going to look like at the end, or what it should be looking like once, how it should be designed. And once you have that, this ID document should also have a detailed, or at least rough estimate of dimensions, length, width, height, and so on. And this would help the designer understand, okay, well, if it's going to be that big, then my PCB needs to be this big, roughly, so they kind of have an idea what's going on. And then where the buttons should be, where the LCD should be, and so on. So all of that will be an ID design, a look and feel of the final product. But the next, also as important, next step is product functionality. And that would give a really important points on what's the max operating temperature, max operating voltage and current, and how should it operate. For example, if it's a telephone, what kind of a LCD we want, what kind of a features we want on this mobile phone, for example. Or so basically the functionality would have all the features, functionality, parameters, and perhaps some of the electrical specifications, or maybe most of the detailed electrical specifications in terms of how they should be designed. And again, I'm just giving you these ideas. They're not written on stone, and every company, depending on the product, they're going to do their side of how they categorize these will be different. Maybe electrical specification is under functionality in one company, but maybe it's under PRD, or user manual in another company. So there's no one cookie cut type of categorizing or writing these information. But as long as you have these sections identified and discussed within teams, I think it's going to help a lot. Number 4, I think, is bill of material is very important. Bill of material gives the picture of what kind of components and materials need to be used and how they need to be sourced, how many of those are in the, for example, in the product, and whether or not the total cost estimate is within the ballpark of the funding or estimate of what the project cost should be, initial cost at least. So I think that bill of material is important to know something about it. And then lastly, step number 5 is when you're designing a brand new product that perhaps maybe only one, competitor has it, it would be good to have a sample of the competitor for competitive analysis and or maybe even re-engineering so that you can design your product even 10 times better in terms of functionality or design or features. Yeah. And then also need to get back to your own customer. If you're designing for a particular customer, understand what the customer requirements are. Perhaps customer wants same product in the in the field, but wanted like smaller version or cheaper version or bigger version. You never know. So it's very important to understand what really the customer wants. Maybe the customer wants an industrial version, which is more robust and reliable, right? So no matter what it is, this step is important because imagine you don't tell your team that this needs to be industrial version and they start developing a product that doesn't even meet industrial version. So you can't ship that product, right? So it is an important step in terms of trying to determine, what to do. So in my opinion, Adrian, I think if you take these 5 steps to a meeting and have a comprehensive meeting from heads of departments and design and development, reliability, purchasing, manufacturing. If you have all these heads of the departments there and you're going through these, you're saying, okay, we have a brand new product that we need to design. Where should we start? Well, that's knowing these steps and knowing these information, not necessarily following these steps in the manner I mentioned. It can be, mixed up, or it doesn't matter, which one is first. Just having these information for each area and knowing what the product is going to look like. And in engineering, sometimes we call it form and fit and function of the product. If you know that, you'll have a big idea or big picture of the product, and then you can easily decide and brainstorm, should we start with PCB first or the enclosures? I think at that time it will be clear. Do you agree?
Yeah, I do. And I think the point that you made about validating it as well for your potential customer is important, because this is all about reducing risks, right? You're reducing the risks of bringing out a product that people aren't going to want to buy. You're reducing the risks of overruns in terms of time, because if something has to be changed, that's going to take time. You're reducing the risks of cost overruns as well, because changes, certainly the closer you get to production, it's going to be more costly. So being organized and having that basis of information, and those 5 points that you've mentioned are really, really helpful for that, will help you to choose the right thing at the right time. So, you don't want to end up making an enclosure, going through all of the time and expense to design it, start producing it, and then it's too small, for example.
Right, exactly. If you start with enclosure and too small, well, for sure, those PCBs are not fitting there. And then on the other hand, if the enclosure is supposed to be small, then there should be a good communication with the PCB team that the typical way of designing the PCB is not going to work. It's just we need to come up with the ways of really small, maybe flex cables instead of, if the product is small, like a digital watch, for example. So there are other ways, that other technologies that they're more miniature. There are many layers to each one of these PCBs. So there are ways of doing these things, but you just have to. I think that rule number one is communication among teams, between cross-functional teams. You definitely have to have very good communication, and I think that project managers and the product engineers who are trying to launch this brand new product, they need to be a good communicator, but also really need to manage the teams in a way that they understand that, if the enclosure needs to be designed first, then let's go with that. Let's not stick to what you learned in another company necessarily. Maybe brainstorm and come up with an innovative new process.
Yeah, great. That's very, very helpful, and hopefully that puts people's minds at rest if they're wondering, well, PCB first or enclosure first. But I suppose in a nutshell, it depends.
It does.
Excellent guidance there, Andrew. Thanks for popping by, and yeah, hopefully we'll get you on again soon.
Thanks, Adrian. Talk to you later.
Thanks again for listening to this podcast, brought to you by the Sofeast Group. We're on a mission to provide you with everything you need to manufacture effectively in Asia, including inspections, auditing, new product development support, contract manufacturing, 3PL warehousing and fulfillment, and much, much more across Asia's key manufacturing areas. Visit us at sofeast.com, that's SOFEAST.com, to learn more and get help. If you've enjoyed the podcast today, please do rate, review and share, because it will really help others discover us too.